Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of permutations and combinations. And if I talk about the question which is given to us here from this topic, the question tells us to find out how many total number of six-digit numbers you can form. So how we have been asked how many six-digit numbers we can form using the digits 4, 5, 9 only, and those numbers which you're forming, that is asked to us that they should be divisible by 6. So we need to figure out that how many six-digit numbers we can form using these three numbers such that the digits or the numbers which are formed are divisible by 6. And if I talk about the answer choice that are given to us here, it is 27, 81, 243, and the last answer choice given to us is 729. So we need to figure out which one of the answer choices is the correct answer for the number of six-digit numbers I can form using these three options, and they should also be divisible by 6. So let's see how do we solve this question. So first of all, if I try to form a six-digit number, I'm drawing six dashes here, and when I need to form a six-digit number, I have been asked that this number should be divisible by 6. So when the number is divisible by 6, it has to be divisible by 2 as well as it has to be divisible by 3. Now for a number to be divisible by 2, I know that the six digit number should be ending up with an even digit such that it is divisible by 2. So for the units place to be even, out of the three options, I have only one even number. So the last option or the last dash which is present, it is fixed for one number, that is 4. So you already have only one option left there, and that number has to be 4. And for the number to be divisible by 3, the sum of all the six digits should be divisible by 3. So if I'm using the idea of divisibility property of 3, I know some of the digits should be divisible by 3 in that case. So let's analyze now and find out how many six-digit numbers we can form using this three digits 4, 5, and 9, and they are divisible by 6. So we have used the idea of divisibility property of 2, and we have got that the units digit should be even, and in that place only 4 can come. So there is no choice for the units digit. But for the other five digits which we have to place, we have the condition that sum of all those six digits which are combined should be divisible by 3. So let's figure out how to solve that question now. So if I try to arrange different ideas here, let's say, so I can have, if I talk about the table, let's make a table here. So I can have 4, 5, and 9 as my selections. And I already know that there is at least one 4 coming up, which is going to be there in the units place. So let's put that first. So if I place 1, 4 only for the first case, so case 1 where we are placing only 1 4s, let's see where do we get the sum divisible by 3. So when I have the 4 placed only once, I have remaining 5 blanks that needs to be placed either with 5 or 9. So I can have 5 5s and 0 9s. I can have 4 5s and 1 9, 3 5s and 2 9s, 2 5s and 3 9s, 1 5s and 4 nines, and 0 5s and 5 nines. So these are all the combinations I have. Now let's just see if the sum of the digits is divisible by 3. So if there are 0 nines, you have this as 0. So 0 into 9. 5 5s, so 25, and 1 4. So you get this sum 29, which is not divisible by 3. So this option is not there. You have 4 5s, so 20, plus 1 9, so 29, and 4, so 33. 33, I see it is divisible by 3. So this remains. 3 5s, so 15, and 2 9s. 18. 18 plus 1, 4, so 22. Not divisible by 3, so this option is also gone. Next, 2 5s, so 10, and 3 9s, so 27. 27 plus 10, 37. 37 plus 1, 4, so 41. Not divisible by 3. 1 5, so 5, and 4 9s, so 36. 36 plus 5, 41, and 1 4, so 45. This combination is also possible because it's divisible by 3. In the last case, 0 5s, so 0, and 9 5s, so 45. 5 9s, so 45, and 1 4, so 49. This is also not divisible by 3. So with case 1 where you had 1 4, you got two cases valid where the sum is divisible by 3. Now let's see the other case. So case 2 where I have 2 4s. Now with 2 4s, I have remaining blanks as 4 out of 6 if I'm placing 2 4s. So I can have 4 0 3 1 2 2 1 3 and 0 4. So these are all the combinations I have, and I have 2 4s. Now let's see how many numbers are valid here. So 4 5s, so 20, and 2 4s, which is 8 already. So that gives you 28. This is not possible because it's not divisible by 3. Next, 3 5s, so 15, and 1 9, so 9. So 15 plus 9, 24, plus 2 4s, so 8, so 32. Not divisible again. So this is also gone. 2 5s, so 10, and 2 9s, 18. 18 plus 10, 28, and 2 4s, which is 8, so 36. 36 is divisible by 4. 1 5, so 5, and 3 9s, so 27. 27 plus 5, 32, plus 2 4s, so 40. Not divisible again by 3. And 0 5, so 0, and 4 9s, so 36. 36 plus 2 4s, 8, 44. This is also not divisible. So you get this option also cancelled out. So with 2 4s, you have only one case where you have 2 5s and 2 9s. Now let's see further. So again, I'll go for 4, 5, and 9. And the last case we are finding is whether the sum is divisible by 3. Now let's talk about the third case where you have 3 4s. So the sum is still 12 already from here. Now when I have 3 4s, I have remaining 3 blanks to be filled by either 5 or 9. It can be 3 0, 2 1, 1 2, and 0 3. So these are all the combinations I have. So if I have 3 5s, it's 15, and 3 4s, which is 12. So that is 27. And this is divisible by 3. So this is possible combination. 2 5s, so 10, 1 9s, 19, plus 12, 31. Not divisible by 3. 1 5s, so 5, 2 9s, 18, 18 plus 5, 23, plus 12, 35. Not divisible again. 0 5s and 3 9s, so 27. 27 plus 12, which is 39. That's again divisible by 3. So this is also a valid option. Now once you have that, let's talk about case 4. In case 4, we have 4 4s. If I have 4 4s, I have here two options left for either to place 5 or 9. So it can be 2 0, 1 1, or 0 2. Now once I have this case, 2 5s is 10, and 4 4s is 16, so it's 26. So that is not possible because it's not divisible by 3. Next, 1 5 and 1 9, so 5 plus 9 14, and 4 4, so 16, so 14 plus 16 30. This is possible value. And 0 5s and 2 9, so 18 plus 0, which is 18, and 4 4s is again 16. So 34, not divisible again by 3. So with 4 4s, I get only one case possible. Now, if I see the fifth case where I can have 5 4s, and when I have 5 4s, the sum is already 20, and I can have 1 5 and 0 9, or I can have 0 5s and 1 9. So 20 is already the sum, and 1 5 would make it 25, which is not possible because it's not divisible by 3. And if I take 1 9, it is 20 plus 9, 29, which is also not divisible. So the last case we get here is case 6, and that gives you 6 fours. And when you have 6 fours placed already, you have 0 5s or 0 9s as your options. And from there, you get 24 as your answer. 24 matches here, and it's divisible by 3. So you get the answer for this also, that you can have 6 fours. Now, once I combine all the ideas that I have found out, that I can place how many fours, fives, and nines so that the sum is divisible by 3. So I can have 1 4. With 1 4, we got how many cases? Two cases where I can have 4 fives and 1 9, or I can have 1 4 with 1 5 and 4 nines. Then I got the second case for 2. For 2, we got only one combination where the fives and nines are 2 and 2 again. And for 3, we got again two cases where it is 3 0 or 0 3. So 3 3 0 or 3 0 3. With 4, you got again one case where it is 1 1. And with 5, you didn't get any case. And with 6, you got one case more. So you get all of these options. Now let's try to find out how many numbers you are able to form with these ideas. That is your 6-digit numbers. So what you had was, you already fixed 1 4 here. Now you already had 1 4, so you only have to fix the remaining 5 blanks. So remaining 5 blanks, we know that n different digits can be placed in 5 different blanks in n factorial ways. So 5 digits can be placed, or the numbers can be placed in 5 digits in 5 factorial ways. So you have your total number of numbers that I can have is 5 factorial. And since 5 is repeating 4 times, I'm dividing it by 4 factorial. So you get 5 into 4 factorial over 4 factorial. This gets cancelled and you get 5 numbers can be formed with 4 fives here. Second option, second case, it tells us 1 4 1 5 1 9. So 1 4 we have already placed, so remaining 5 digits can be filled in 5 factorial ways. And since 9 is repeating 4 times, we divide by 4 factorial. So again, you get 5 6-digit numbers can be formed in this case as well. Next, if you see, you have 1 4 already placed, so only 1 4 needs to be repeated. So remaining numbers or remaining digits can be filled in 5 factorial ways. But here, if you see, 4 is only once extra because you have already placed the last digit, right? So that you are not filling it again. So you don't divide by 2 factorial because of 2 4s. But if you see, 5 is repeating 2 times, 9 is repeating 2 times. So you divide by 2 factorial because of 5, and you divide by 2 factorial because of 9 as well. So you get 5 4 3 2 divided by 2 into 2. So you get this 4 cancel with this, and you get 36-digit numbers you can form in this case. Next one. For the next case, you have placed 1 4, but you are placing additionally 5 factorial divided by, you are placing additionally 2 more 4s. So you are dividing by 2 factorial. And here you are placing 3 5s repeatedly. So you are dividing by 3 factorial as well. So you get from here 5 factorial, which is 5 4 3 2. 2 factorial, which is 2, and 3 factorial, which is 6. So this 6 cancels with this and 2 cancels with this. So you get 10 numbers in this case. Same case again here, instead of 3 5s, you have 3 9s. So you get that same thing, 5 factorial divided by 2 factorial into 3 factorial, which will again give you 10 numbers. With 4 4s, you have 5 factorial because you are placing only 5 digits. One digit is already filled with 4. And apart from 4 4s, you have placed 1 4, so you have additionally 3 4s placed. So since 3 4s are repeating, you're dividing by 3 factorial again. So you get 5 4 and 3 factorial, which is divided by 3 factorial. So this gets cancelled here. You get 20 numbers in this case. And the last one, you are placing 6 fours. 1 4 is already placed, so remaining blanks are placed in 5 digits. That can be done in 5 factorial ways. And additionally, apart from 1 4, you are placing 5 more 4s. So you are dividing by 5 factorial as well. So in that case, you are getting entirely this cancelled and you have only one 6 digit number which is combining of all digits as 4. So you get this many number of total 6 digit numbers. So if I find out how many total 6 digit numbers you are able to form using 4, 5 and 9, you get 5 plus 5 plus 30 plus 10 plus 10 plus 20 plus 1. So you get 35, 40, 50, 60, 80, 81. So in this case, you get 81 6 digit numbers you can form, which are divisible by 6 and which are formed using only these 3 digits 4, 5, and 9. So that matches with option B, and B becomes the correct answer for the question given to us here. I hope you have understood how to solve this type of questions, which deals with the ideas of forming a 6 digit number using 3 options only, and also it had to be divisible by 6. So I first bifurcated 6 as 2 into 3. 2, we know the divisibility property that the number form should be even so that the units place can only contain 4. So that position is filled already. Then we found out the number of options that I can have for this remaining 5 digits to be filled, where the sum of all the 6 digits become divisible by 6. So I had various options here, and once I had all the options with me here, I figured out how many total number of numbers I can have here in each case that I have, and that turned out to become 81. And that matches with option B. So B becomes the correct answer for the question given to us. I hope you have understood how to solve this type of questions. I'll see you again tomorrow with some other question from some other topic. And we are going to continue our series of questions on JEE mains. So stay tuned for more videos to roll out. Also, if you're enjoying these videos that we are doing every day, please do like the videos as well and do subscribe to my channel. Do share these videos with your friends also who are involved in the preparation of questions on JEE, so they can also take the benefit from these questions which we are solving on everyday basis. See you again tomorrow with one other video. Thank you.